Hey gang, Private Jack here. This is part 3 in my QCI series, and in this video what I hope to do is actually find the coordinates, write the QC, fix the VMTs, export, compile, and get this thing into a source engined game, such as Source Filmmaker, Gary's Mod, TF2, that kind of thing. So, my primary focus here is on Source Filmmaker, and that's what I do my modding for. For you guys that think my videos are too slow, they're too long, that kind of thing, yes, I agree with you, they are. And simply due to the fact that when I first started out doing these videos, or when I first started out doing Blender, all I had to work from were speed videos, and trying to work my way through learning the process, it was a real pain in the butt. Anyway, so I do my videos for new users or people new to a process, and I try to explain in detail what I'm actually doing to get the thing to work. If you can get away with just watching a speed video, good for you. I might include one at the end of this series in part 4 and just do a speed video so that you can try and guess at what I'm trying to do. Anyway, with that, let's get on with this. First, I'm going to do a quick recap. This is Blender. We've gotten a model from the web, or we've decompiled, or we've created a model. We want this model to use QCIs in Source Filmmaker. From here, what we did is we created an armature, and we weight painted the mesh to the armature so that the model deforms the way we need it to for use in game. From here, we actually went through and we, unwrapped the model. Using the UV islands, we created textures, and those UV islands, and we assigned those textures to the UV islands so that they work properly on the model. So here's that model actually textured. We'll close this off. We'll close this back down. Now, currently, this model is using this particular texture on the left eye. I've got it set up so that it's using these two textures on the right eye. And in part 2, I showed you how to set up a shader node so that you can emulate QCIs in Blender. Okay, now that that's shown, I can't emphasize enough that these two textures, okay, for QCIs requires two textures. One for the whites of the eyes and one for the iris. Anything that is not transparent on the iris texture is going to be overlaid onto the eyes white, or onto the whites of the eyes, and it's going to float on that particular texture. So if you want to add things like blood vessels or whatnot else, you're going to want to add them to this material. Anything that isn't transparent is going to be shown on that particular texture, and is going to be movable on that on the whites of the eyes. I can't emphasize enough that these two textures have to work in unison together. They have to work with the UV map for the whites of the eyes. Each eyeball must have its own material. Now, where did my properties panel go? Okay, we'll get out of pose mode, and we'll select the eyeball, and each of these eyeballs must have their own material. So if I've got a left, right, center and lower eye, each of those eyeballs must have its own material. In this case, I've only got two eyes, so I've got an eyeball right and an eyeball left. And these textures work in unison together to form a proper looking eye, like this. Okay? Now here I've created two iris textures, and I've put them together with this particular whites of the eyes texture. When I look at it in Blender, it looks like this. That's the way that the actual UVs are using this particular texture mix. When I get it through to Source FilmMaker or the Valve Source Engine and get QCIs working, it's going to look like this. And it doesn't matter how I adjust the coordinates for the actual QCIs, these eyes are not going to work. This is using it properly. The actual UVs are laid out so that this iris uses this texture properly. The UVs are laid out. The eyes look like this in Blender. And when I get finished with the process, they look like this in Source FilmMaker. Okay, so that's a quick recap. Let's get on with it. Here I have Blender, and as I said, I am using Blender 2.9 beta. This version of Blender should be releasing pretty soon, sometime near the end of January, maybe middle of February, but it will become the stable and it will be the one that is downloaded from Steam. I'm using the beta version right now to prove that the add-ons that are currently available still work in the new version that is going to be released. Now, for the coordinates, before I start looking for coordinates, I'm going to set up Blender. First off, if I move my cursor around and start selecting areas on the model, if I don't set up my cursor to sit on the outside of mesh, when I move the cursor on XY or XZ or YZ coordinates, that cursor is not going to sit on top of the mesh. To fix that, what I do is I come into Edit, Preferences, come here to the Editing tab. Right here, I'm going to turn on Cursor Surface Project. I click that on and just close the preferences. Now when I click the cursor will actually determine the depth of the model and sit on the outside of the mesh where I click it. It's not going to bury itself inside the head or whatnot else. This way, when I start using coordinates for that 3D cursor, and I open up my transform menu, come down here to the View tab, and here are the actual coordinates for that cursor. Don't worry about rotation. You can set that to 0 or just leave it as it is. We're not moving anything around in the scene. We're just using the cursor location to gather up coordinates. Next thing I'm going to do is I'm going to come here into the Scenes panel, and currently my measurements are using meters. This might be meters, centimeters, millimeters, whatever, or if it might be using imperial, that's feet, pounds, inches, that kind of thing. Well, the QC that we're going to write doesn't like those type of measurements. What it wants is Blender measurements. And to fix that, what we do is we come in here and we change the unit scale to none. Now these actual values are Blender units in the Blender world space. Last thing that I do is I set my view mode to orthographic. To do that, all I do is press 1, 3, 7, Control 1, Control 3, and Control 7 on the numpad. So in orthographic mode, now I'm ready to start gathering coordinates. Let's look at the QC. Oh, before we go there, what I suggest is that if your model is now ready for export the way it is, I suggest that you actually export it and compile it and get it into Source FilmMaker. Because there's nothing worse than going through this entire process only to find that your model imports and looks like this, or that the model is not scaled properly to work with the elements of the universe that you want to use it with. So what I suggest is that using the combination I textures, you get it into Source FilmMaker, have a look and make sure that the eyes are displayed properly on the model in Source FilmMaker. Check any of the flexes that you happen to have on the model. If you have skins, make sure that all the skins work properly. Actually pose the model using bones to make sure that the model deforms properly. And if you have a IK rig or plan to use one with the model, you either load or create it and actually pose the model around and make sure the IK rig works properly. If you have to come back and make any changes and you've already gone through and made the QCI process, you're going to have to redo the process again, because anything that you change on the model, you have to re-export, recompile, and that may change the actual coordinates that you're planning to use. Before we get started looking for coordinates, I'm going to go over a quick recap on how I set up Blender. I'm using version 2.92.0 beta. This is the next version that's going to be available on Steam. It should be released in January, middle February, sometime in around there. And this will be the standard version. The reason why I'm using the beta is just to prove that the add-ons that I use still work in the next version that is coming out. Okay, to set up Blender, what I do is, first off, my 3D cursor. If I move my 3D cursor right now and I tap somewhere on the model, the 3D cursor is going to move. It looks like it might be in the proper position, however, it isn't. And I want to use my 3D cursor to actually get coordinates. I need this cursor to float on the outside of the actual mesh. So I'm going to come in here to Preferences, come down here to the Editing tab menu, and I'm going to turn on Cursor Surface Project. Now if I touch the model, the cursor is going to stop and rest where I touch the model on the actual surface of the mesh that I touch. Next thing I'm going to set up is units. Over here in my Properties panel on the Scenes tab, here in Units, currently my model is using metrics. If I open up my Transform menu, pressing N, and I come down here to View, and I look at my cursor location, it's using metrics. When we actually get into the QC and we start placing coordinates, the QC wants actual world space type coordinates. And the way that we do that is by coming in here to the unit system, expand units, unit system, and we change it from whatever it is now to none. This means that the coordinates that we get here in the location are going to be Blender world space locations, and basically this is what we need for the actual QC. The other thing that I use is I use orthographic mode. To get into orthographic mode, you use the numpad and press 1 to come into front view, 3 to go into the right side view, 7 to go into top view, Control 1 to go into back view, Control 3 to go into the other side view, and Control 7 to go into the bottom view. So I use numpad 1, get into the front view, and basically from here I can actually now zoom in on the model and get close and personal with the eyes and start my gathering up locations. Another little trick that I have is that if I can move the camera around to use the cursor as the actual focal point of the view camera. And to do that, what I do is I turn on Lock to 3D Cursor. Now when I move that cursor around, the camera is going to bounce around wherever I put that 3D cursor. Getting close and personal on the eyes. Boom. 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 And that kind of thing. To turn it off, all I do is uncheck it, and the camera will bounce back to its normal view. So, first off, I'm going to get in here real close and personal with the eyes. If you've imported SMDs and have those great big huge globules for bones, what I suggest you do is turn off the armature. Just hide it. Use the outliner and click on the eyeball. Now what I'm going to do is I'm going to try and put the cursor where I think the center of the eye is going to be. Okay? If I back off the actual model now using the scroll wheel, that cursor is going to start filling up the eyeball. And it looks like I've got a good location there for the actual first coordinates that I'm going to use in the QC. QC eyes are defined in the QC. If you actually went through and did the process of exporting the model into Source FilmMaker before you started this process, you already have a QC. And this is the QC that I had that created that model that you saw in the last picture. Okay? QC eyes requires elements. And the only thing that's different between this QC and the actual template is I have attachment statements and I have a model statement. These are the only things that really need to be moved into the QC in order to get QC eyes to work. So I'm going to pick this up. I'm going to copy it. I'm going to go back into my QC that I created the model with. I'm going to paste it so that now I have those particular elements in the QC that I was working with. For QC eyes, what we require is attachment statements for the eyes, and what this is both eyes. It's a coordinate that is in the middle of both eye white meshes. We need one for the right eye, one for the left eye, and any other eyeball that we actually have. We need attachment points for every eyeball. We also require a model statement. Now, the model statement is where we define flexes. And basically, with DMX exports, we have a lot more flexibility than we do with SMD exports. My flexes, like the shape keys, I've got a shape key on this particular model. If I come down here and I select that. I have a flex key here in the face. Okay, it is part and parcel of this particular body group. I also have separate mesh for my eyes, and I want the QC eyes to be on this mesh. Okay, so here I have the flexibility with DMX exports of actually doing that. If I'm doing SMD exports, however, and this is a typical SMD type QC, what you're going to find is that we are going, if we have flexes, shape keys in the model, it's going to create a VTA file. All flexes, including the eyes, must be defined in a model statement. And we really can't have more than one model statement per QC on an SMD export. So if I was going to do SMD exports, I would actually have to join this mesh to the other mesh that has actual flexes and start my definitions here in this particular model statement. Now, here's something else. You guys that use this command in your QCs, stop watching the video right now, because if you're exporting SMDs, nothing is going to work. If you're exporting DMX files, only your flexes are going to work. The QCIs won't. And the reason for that is simply due to the fact that if we go into the developer wiki and look up the actual wiki on the scale command, right here it tells you the scale command multiplies the size of the subsequent model files. It does not affect values defined in a QC itself. So any coordinates for attachments, eyeballs, flexes, and whatnot else are not going to scale when the QC runs. So all those things are still down in their regular positions, and when we get it into this game engine, those coordinates are not going to be to the actual model that was compiled. So it's going to break them. DMX and flex animations, like shape keys, the shape keys are written into the actual mesh of the model, and when we compile it, it will actually multiply or divide or whatever it does, scale the flexes with the actual scale command. However, because QCIs are actually written coordinates, it does not scale the eyes. The eyes will not work. The flexes will. Okay, so that's scale. Like I say, if you're using scale commands and doing SMD exports, your flexes and your eyes will not work. Let's get back here. Okay, so now we've got this information here in our QC that we've actually compiled a model with. In order to fill in the blanks here, we need some coordinates. And then we need the rest of the information that we're going to have, that we are going to require. So here, first coordinate I'm going to do is the left eye attachment. Like I say, I want that cursor pretty much in the center of the eyeball. All I have to do now is come over here into my cursor, and you have to be careful touching this particular value, because you can actually move the cursor when you click the button. And using a Control Z will not put it back to the value, it will not put the cursor back to where it was. So I'm going to click the center of the eye again. My cursor currently is sitting on the outside of the eyeball. It's in the center of the eye. So now I'm going to click in here, careful not to change the value, copy that X value, come over into my QC, into my left eye statement, attachment statement, and I'm going to start replacing the X, Y, Z coordinates. So this is the X. In Blender, I can use the Tab key and the Shift Tab key to change between the values. So I'm going to use Tab. I'm going to do Control C again to copy that value. Come back into my QC, put a space, Control V. And that will put in the Y value. Again, Tab, Control C, back into the QC, Control V as in Victor. So now I've got an actual attachment location coordinate set. For the right eye, if your model is symmetric, meaning that the left and right sides are pretty much the same across the Z axis, to move this cursor into the other eye to get the coordinates for this eye, instead of actually coming in here and tapping on it, all I have to do is come into my 3D cursor X position and make it a negative number. The cursor is going to pop over to the other side, and that should be pretty much center of the eye for the left eye. That's if it is symmetric. If the model is not symmetric, or the eyes are slightly offset from the center line, what we need to do is actually move the cursor around and take the coordinates from here and put them into the right eye attachment coordinates. Because my model is symmetric, I'm just going to use these values, and because it's symmetric and all I did was flip it over to the X, over to the right side, I can actually come back in here, pick up the values that I've already used, copy them, move up to the right eye attachment, Control V, and just change this to a negative number. And that becomes the same as what I've already got here. For the eyes, what the eyes are, the eyes attachment is the center point between the two eye whites meshes. So what we do is we come in here, we go into edit mode, we select the vertex from the eyes left, or the eyes right, Control L to select it all, hold down the shift key, select the vertex in the eyes left, and press Control L, and we select the actual mesh that makes up the eyes white. Now, if you're into a situation where this is not a separate object, the best way to do this is to actually come down here into the actual materials, select the eyeball right material, press select, select the eyeball left material, press select, and then use a Shift S and move the cursor to the selection. That is going to move this cursor so that it's in the center of the two meshes that are selected. As you can see, my model is pretty much symmetric, and so for my values, what I'm going to do is I'm just going to pick up the YZ coordinates that I've got, copy those, come up here to my eyes attachment, drop those in here, And then for the X location, I'm just going to put 0. So that has the coordinates now set for my attachment statements. These are initial coordinates, and we're going to be playing with these as we go through compiling builds. Now, to finish off the statement, it is important that the actual names of for the attachments and for the eyeballs be exact. Okay, so this eyeball is going to be looking at that right eye attachment. The left eye is going to be looking at this left eye attachment, and we'll take the S out of there. And the eyes are going to be looking at the eyes attachment. It's important for the model statement, it's important that the eyeball commands are in this order: right eye, left eye, and that the actual flex controllers are up, down, and left, right. If these are mixed up, your eyes are not going to work properly or not at all. Okay. Finishing off the attachment statements. The attachment command requires that the attachment be named, and I'm going to use eyes as for the in-between point. The attachment bone is, if this attachment is being driven by a bone, what bone is going to actually drive it? Well, the eyes are in the head. So I'm going to use my outliner here. I'm going to expand the skeleton, and I'm going to find the head bone. Way down here. Here's the neck, here's the head. My head bone is called bip head. So I'm going to copy that. I double-clicked on that so it would select. I'm going to use Control-C, come back into my QC, and I'm going to replace this variable here with the name of the actual bone that is going to control that attachment, bip head. The eyes right, or the right eye and the left eye, they're going to use the same bone. So I can replace those at the same time. Over here for the rotation factor, if we actually look at a model that is compiled by Valve, and in this case the sniper model, I'm going to find that for a rotation value they use absolute. This means that this attachment point is absolutely there, and we're not going to rotate anything on it. So for the attachment point, I'm going to use absolute. And it's going to be the same for all three attachments. My attachment statements are now complete. For the eyeball, this is the initial compile. First off, as I have already stated, eyeballs must be defined in a model statement. Okay? So basically, this is where we define eyes. We can't define them in a body statement. We have to give that body group a name. And in my case, I'm just going to call it Cynthia, if I can spell, eyes. If you open with a quote, make sure you close with a quote. If you have spaces in a variable like this, you have to use quotes. Now, this object is going to be exported as a DMX file. What is the name of that DMX file? Well, all I have to do now is come back into my model. I'm going to minimize this and come into object mode, and I'm just going to select objects until I find my eyeballs. There's my eyeballs. Now, if this eyeball was connected to the face, I would look for where the actual eyes white material, or the eyes white mesh is located, what object it's in. But for me, I've got it as a separate object, so I'm just going to copy that. And I am going to drop it right here. Get rid of the quote there and put it on the end of the actual file name. The models command opens with a curly bracket. We do a hard return, and then we start defining eyeballs. From there, after the eyeballs are defined, we come into flex controllers, and we define them, and the model statement is closed with a closing curly bracket. Curly bracket means group. All this stuff is part and parcel of that group. Again, with the SMDs, if you're exporting SMDs, if we look at this, we've got the model statement opening. We're defining eyeballs. Then we're actually telling it it has a flex file VTA. We're opening a group there, defining all the flexes, and closing that particular group off. We're still within the first group. We're defining all the flex controllers for the actual shape keys. And then here we find that we're defining the actual flex controllers for the eyes. Then we're defining local variables and that kind of thing. And then finally, we're closing off the group for that model command. So all of this stuff is part and parcel of this model statement. Heck of a lot easier to export DMX files and only have to define eyeballs. Now, the models command will create the mesh for this particular body group. Here you see I've got a body statement for the eyes. If I leave that in here, what's going to happen is this is going to duplicate that particular body group. And my eyeballs may not work because what I'm seeing is one mesh on top of another mesh. I have to delete the body statement for that eyeball mesh. Okay, so this is going to create the mesh for that. Then if I look at my actual other exports, I've only got two other exports, the head and the body. Here I've got body statements for the head, and I've got body statements for the body, and I'm just going to change that to change the names here for those actual body groups. And the rest of my QC. Now for the coordinates. This is my first compile of this particular model. I'm just going to use the same coordinates that I have here. I know that these eyeballs are not going to work. I've got to get rid of that bracket properly, but it should give me something to actually view when I actually compile the model. So right eye, left eye. The mesh bone name, what bone is actually driving this mesh? Well, it's still in the head. It's going to be the BIF head. This statement is the VMT name for the whites of the eye material. That is these right here. Eyeball right, for the right eye, and eyeball left for the left eye. And if I had other eyeballs, I would be defining eyeball commands here for the other eyes. I'm going to wrap those in quotation marks, just so that I can distinguish where I'm at in the QC. And again, if you're using spaces in any of your names, you have to include them in quotation marks, or when you compile, what's going to happen is it's going to come through, it's going to say, I found eyeball, but I expected a value, and I found left. The diameter of the eye is the width of the eye. For this, I'm just going to, my initial compile, I'm just going to change that diameter to 1. This walleyed factor that I'm identifying here, if we go into the wiki again and we look up eyeball, right here, diameter, angle. This is what I'm referring to as that walleyed effect. Okay, right, that walleyed factor. And what this is it's the default yaw offset from directly looking forward for the iris. Most humans are 2 to 4 degrees wall-eyed, which means that the eyes are more or less tilted in towards the nose. Okay? With this factor, if you don't set it or it's not set correctly, your character can either look cross-eyed or it can look bug-eyed, where the eyes are pointing outwards instead of looking kind of straight on. When you look at a person, their eyes aren't really straight out. They're tilted slightly in towards the nose. So this value should be a negative number for the left eye, and it should be a positive number for the right eye. So for the right eye, instead of actually setting up this factor now, what I'm going to do is I'm just going to set it at 0. And the same for the left eye. Once I get the model into Source FilmMaker and I'm able to see the eyes properly, I can start adjusting this factor -2, -3, -4, -145, whatever, right? Or positive, that kind of thing. This value here is for the iris material. We don't use it from the QC. We get this information from the VMT for the actual eyeball. So we can just incorporate a not used in here, because this particular value has to be in the QC, or it will not compile. The iris diameter I set to 1 to start. And basically like that. So here now we've got the right eye defined. We have the bip head as the bone. We've given it a coordinate the same as what we gave the coordinate here for the right eye attachment. The right eyeball uses the eyeball right material. The diameter of the eye is 1. I'm not setting a walleyed factor. The iris material is not used. And the actual diameter of the iris is going to be 1. Off to the flex controller. The flex controller uses the eye's attachment, whatever this value is here. If I use a different value here, then this value has to be the same as that. The range is, the top controller is the up-down controller. So the range here is negative to go up and positive to go down from the center point of the eye, right? So here I'm going to set this as an initial value to minus 90, positive 90. And this is important. If you want the eye flex controller to show up where it has to show up and create view targets and the eye convergence and the local view target factor sliders, it must be named eyes up down. And it must be an underscore between eyes and up down. For the flex controller for the left right or right left movement, range, it's still using the eyes attachment. Range is going to be negative to go right and positive to go left. So I'm going to use the same values, minus 90, positive 90. And the flex controller must be named eyes right underscore right left. Again, not naming it properly, that controller will end up down in the unknown. The local view target will not be created, and the eye convergence will not be created, and the local view target factor sliders will not be created. I close off with a closing bracket, and this particular QC is ready to go, with one exception. Here, what I'm going to do is I'm going to rename the model, and I'm going to call this one Cynthia QC Eyes Test 1. This way I'm not overwriting the model that I compiled earlier, and anytime that I do a recompile, by changing this number, I can create a new model and not have to open and close Source FilmMaker every time I do a compile. So this is ready. And what I'm going to do is I'm going to now come into Source FilmMaker. If I don't have Blender Source Tools set up, I'm going to set up Blender Source Tools so that I can export, compile, and get the model into Source FilmMaker straight from Blender. So here, the export path, this is where the Studio MDL exe file lives for the particular game that you are, export path. Export path is where you are going to send your DMX files. So I'm going to click on that folder there. I'm going to go to my desktop, and I'm going to create a new folder, and I'm going to call it Cynthia QC test. Actually, I'll call it toot. I'm going to drill into that new folder and click on accept. That means it's going to go here. Now, if you see your file paths looking like this, it means that it's using relative referencing. Okay? I don't like relative referencing. When I look at my actual paths, I like to see exactly where they are going. Another setting in the actual preferences here. And is it system? No. Save and load right here. Save and load. I'm going to turn off default to relative paths. And now what should happen is if I select that folder again, I'll have to clear it first, I think. I now see the actual folder path where these DMXs are going to be sent to. The engine path is where Studio MDL for the actual model resides. We'll get into these two in a minute. This is where the Studio MDL that you're going to use to compile the model actually lives. In the case of Source FilmMaker, it is in the Program Files x86, Steam, Steam Apps, Common, Source FilmMaker, Game, Bin folder. And Studio MDL is right there. Once I've got the folder selected, I don't have to select Studio MDL. I just click accept because all we're looking for is a path. I'm going to be exporting DMXs because I don't want to get into writing VTAs for my flex controllers. Z-axis is up. That means that the model is standing on the Blender floor and the up axis is this way. If she was lying on her back on the floor, then it would be Y, right, or X, whichever way the head is pointed. Material path, I leave blank. I allow my QC to actually call materials. And let's see. I'm not going to export any animations. I have one flex controller in this particular object. I'm going to make sure that the basis key is selected and that none of the flexes or shape keys that I have a value other than 0. If you do, what you can do is just click this X button and they will all default to 0. If your models are part of collections, and I don't have that set up here and I don't really want to get into it, but let's send this off to another collection. Blender source tools will export model, combine objects together and export them as collections. And the collection name will be collection whatever.dmx. I always turn off or suppress collections so that I just get object DMXs. So you select the collection, come here into the group properties and click suppress. Now I'm going to get pure SMD files for every body group that I have in my model. Not going to get into flex properties. This is simple and advanced. And then down here in the game path, what you want to do is you want to point the game path to where the game info text file lives for the game that you are compiling for. In the case of Source FilmMaker, that is in Source FilmMaker, Game, User Mod. And right here is the game info text file that Blender Source Tools is looking for. Click Accept. Now, the QC, I save my QCs to the same folder that I am going to export the model to. So here, I'm going to click on this file browser, come up here, and I'm going to find that I want this to go into Cynthia Toot. Cynthia Toot doesn't exist. So I'm going to create a, let's get up to desktop. Maybe it does. Yeah, there it is. Okay, so Cynthia QC Toot. I want this QC to reside in that same folder. So I'm going to select that folder, click Accept, and that QC that QC area, click Accept, will turn red. It will stay red until such time as it finds a QC in that particular folder. So now that I've got my QC written and I haven't saved it anywhere yet, I'm going to go File, Save As, go to my desktop, go into that QC Toot folder. I'm going to change my save file, my save as type to all files or all types, so that when I save it, the program doesn't add a .txt extension to it. And I'm going to call this one Cynthia QC eyes toot.qc. I'm going to save that file, and as soon as Blender Source Tools sees that particular QC in that folder, which it didn't, because I cleared this off, it's going to turn this value, this from red to this color, and it's going to pop in a clickable button here named the same as your QC file. Okay, I am ready to start exporting. We know that the model exports and comes into Source FilmMaker correctly because of the fact that we've already compiled it once. We've added new elements to the actual QC. So now we're going to export the model again. We're going to export the 3 scenes that are in the model. And we're going to get a notification down here that 3 files were exported. If I actually want to see what actually happened, I can come in here to the Windows Toggle System console, and here I can see those 3 files being baked. Took a total of 2.6 seconds to bake all 3 files. Now I'm going to compile the model. Remember, this model is going to compile. It's going to go to my user mod models. Models is assumed in the model name. Private Jack, characters, Fire Emblem, Cynthia, and it's going to be called Cynthia QCI Test 1 MDL. It's going to look for my materials in a mod folder like user mod, materials, and it's going to look for them in the mod folder, materials, models, Private Jack, character, Fire Emblem, Cynthia folder. Okay, so I'm going to click on the compile button. We'll get a message down here saying that the model either compiled or there was an error. if there was an error, we can go back into our system console and look for the error. This one compiled okay. Everything went through all right. Here I can see it compiled the model. It compiled 2 eyeballs and 1 flex animation. And now when I go into Source FilmMaker, which I don't have open, I'm going to launch Source FilmMaker. Create a session, load a map. I'm going to use stage. Open that. When the map loads, I'm going to right-click in the animation set editor, create an animation set for a new model, and I'm going to look for that Cynthia QC model. So here's my actual test model. I'm going to open, select it, look down here, see if there were any actual errors for textures or whatnot else, and open it. Back out, go into edit mode, the motion editor, select the model, and I'm going to default it. Now if I look at the model and I zoom in on the eyes, my goodness, those eyes look fantastic. However, they don't move. Now, what's the problem here? Well, basically, I've set it all up, but my model is still using the Vertex lit generic textures or materials for the eyes. What I have to do now is I have to fix my VMTs. So back off to our text editor. I'm going to open up the eyeball right and the eyeball left textures or materials. And currently, this is the actual texture that is being used. It's a Vertex lit generic texture. It's using that Cynthia eye, which is the combination iris and eye white material. And what I need to do is I need to change it to use an eyes shader. And I have to change the base texture to the whites of the eye texture. And then I have to give it an iris statement saying what texture to use for the iris. So I'm going to take, I've already got it set up here. I'm going to delete that. It's now using the eyes. It will now use the eyes shader. It will load up the whites of the eyes texture, and it will overlay this iris texture on top of that. I file save. Replacing the eyeball right material with this, I can now pick this up, copy it, go into my eyeball left material, paste it, change the values here for the textures that are actually required. If I have different, if my left eye is using different textures than my right eye, replace this on my left eye material. Come back into Source FilmMaker, and now I'm just going to type in here mat underscore reload all materials. Let it whirl around a little bit. If SFM doesn't crash, I'm going to grab a hold of the playhead and I'm going to move it, and something happened. I've got iris material, but I don't have eye white material. I've screwed something up. I probably grabbed the wrong texture, or it doesn't exist. So now I go off to where I have my materials stashed. I currently have them in the workshop folder, materials, models, private jack, characters, Fire Emblem, Cynthia, and what I need to do now is I need to find, and what we're going to do is we're just going to, I have a Windows shell extension on my particular system that allows me to view VTFs in Windows File Explorer. And I'm going to change the view to medium icons, and the one that I want is called White's VTF. Not eyes white. So all I have to do now is come in here, replace that, save it to my, save the eyeball left, select the eyeball right now, and replace that texture. File save that now. Come back into Source FilmMaker and reload all materials again. And poof. What we have now is we do have the eyes white. We have the iris sitting on top of it. However, the pupil size is the iris size is incorrect. If I come into the actual model now, I will find if I created the flex controllers correctly, I will find that I have a face control. Open that up. Inside there, I'll find an eyes control. I'll have my eyes up, down, left, right, local view target factor, eye convergence, and view target. Now, if I try to move the eyes, what's going to happen is that they're not going to move properly. Remember, this is only my first compile, and what I want to do is I want to get the eyes visible in the proper place. And now what I have to do is I have to go through and I have to correct some coordinates. So back to the QC, back to Blender, currently, and I'm going to grab the XYZ coordinates for the right eye. Come in here to my View tab in my Transform menus. Come here into the 3D cursor. Drop my X. Tab there. Copy. Drop my Y. And my Z axis locations. Oops. Control Z. Let's grab it first. Control copy, Control C, Control V, and that's going to snap that cursor right there into the left eye, or the right eye. I'm going to make this a positive so it comes back into my left eye. And what I need to do now is I need to figure out a spot for this particular cursor. And by a sweet spot, what I mean is you can consider the cursor a bone. What I need to do right now, that bone is sitting right on top of the eyeball. And because it's sitting on top of the eyeball, if I try to use a rotation factor up, down, left, right, it's got nowhere to move that texture. What I need to do is I need to pull this Y-axis back into the eye and start figuring out where the sweet spot for the rotation spot is for the eyeball. To do that, what I'm going to do is I'm going to click on the Y axis here. I'm going to hold down the Shift key and I'm going to pull that cursor back into the head, probably about there. Now, because this is actually maybe a little bit, actually we'll just leave it where it is. The X factor is fine. Looking at the eye, it's in the center of the eyeball. The Y factor is wrong because it doesn't move. The pupil factor is wrong, or the iris size factor is wrong because it's too small. So here now, what I'm going to do is I'm going to grab a hold of that new Y factor, copy that, come in here to my actual attachment statements and replace, or into my statements and replace the Y factor for all of my controls, my attachments and my eyeballs. Search, replace. It's going to pick up that value, and I'm going to Control V into here and replace all. So now the Y factors are all the same. Here in the actual iris size, I'm going to increase that to say, let's go 5. The model name, I'm just going to change that 1 to a 2, so I'm creating a new model. I'm going to file save the QC. And because I didn't actually make any changes in the model itself, all I have to do is recompile the QC. I got a good compile. Now I'm going to hide this particular model that I've just imported. I'm going to right click here, create a new animation set for a new model, and it didn't find it. Well, what I have to do is, because the models are already cached, I have to do a rescan. Here's that new model. I'm going to select it, import it. I'm going to select it. I'm going to default it in the motion editor. And now I find that my iris size is way too big, or my iris size is way too big. Currently, it looks like the eyes are looking downward. If I use the up-down controller, I find that the eyes move. But why are they looking down? If I use the right-left, they kind of move right and left, but they're still looking down. Why are they looking down? It's because they're looking down here at the view target. The view target is down here on the floor, and it's in the center of the model. So these eyes are being controlled by this view target. What I can do is I can grab the view target and bring it up to eye height and watch how the eyes move using the view target. The eyes are way too big. Or I can leave the view target where it is, and here at the local view target factor, I can negate the influence that the view target has on the eyeballs, meaning I'm calling it out, and the eyes should spring into the actual look forward position where they need to be. Still, I can see that the eyes are still too big. If I use the up-down buttons now, yeah, they're moving, but they're not moving properly. And the right-left, they're not moving properly again as well. So, back to the QC. 5 is too big. Let's go with a 3. because I want to get the eyes more or less looking properly on the actual model before I do any more adjustments to the actual pivot point, I'm going to change the model name, change that to a 3, save the model, save the QC. And because I didn't do any changes, all I have to do is recompile. And the model compiled. And now we're into the thing about QC eyes, where we're trying to find the proper iris size and the sweet spot for that particular pivot point. This can take a few models, or it can take many, many, many models. It's also why it's important that these eyes use those UV maps correctly. So here, now what I'm going to do is come into the face. I'm going to negate the view target. Those are looking pretty good. However, they might want to be a little bit bigger. Use the up down. They move up, they move down, and they're moving in a straight line, but they're stretching a little bit. Use the make sure that's defaulted. Kill off the target influence, right, left, and we can see that the eyes are kind of tilting and moving, not in a straight manner. Okay, so that means, one, our eyes are probably too small, and that pivot point is still not in its sweet spot. Come back into the model. Let's pull this pivot point back a little bit more, and maybe raise it a little bit. Maybe right about there. Okay. Now, because we didn't touch the X factor, because we think that those eyes are looking pretty good the way they are. In the center of the eye. We might want to increase the walleye factor a little bit. But we want to get the eyes, again, we want to get the eyes looking proper in the actual eye socket and find that sweet spot for the eyes. So here in the QC, I'm going to increase that to about 3.5. I moved the the Y and the Z locations, so I'm going to come back here into Blender, tab into the Y, copy that. I can select this value for the Y, come in here, do a search replace, drop the new Y value in, Control V, replace all. I changed the X factor, or correction, the Z factor. Copy that. I'm going to select the Z information here now. I'm going to do a search replace, and that should change the value here and find what. Drop in the Z factor, replace all. File save the QC. Oh, before I do that, I'm going to change the model number, or the model name. File save. And come back into Blender and recompile. Model compiled, okay. Back into Source FilmMaker. Hide this model. And the process goes on until such time as you get everything looking right. Here's test 4. Open that one up. Default it. Let's kill off that view view target. Eyes are looking much better now. And the up, down is looking good. The right, left is looking good. So it looks like we've got that pivot point pretty much good. The eyes are good. Whether or not we want to pull those eyes down by moving the UV map now is another question. The Walleyed effect, well, that's not looking too bad at 0. But if we wanted to test that out, what we could do is come in here, and this one is positive. The right eye is positive. The left eye is negative. Change the model number or name. File save. Hide this one. Compile this one. New model, rescan, test number 5, default, model's looking down at the view target. Let's negate that. Notice how the eyes moved. They're moving in towards the center, in towards the nose a little bit. Up, down, right, left. That's looking pretty good. Now, if I wanted to increase the range of the actual eyes themselves, I would start changing my flex ranges. And basically, this one is pretty much done. So, how did the skins turn out? Well, let's have a look. Let's change the skin. We know that the skins work. Oh, they look wonderful. However, the up-down doesn't move. The right-left doesn't move. The view factor doesn't move. It's because they are still using the vertex lit generic texture. Come back into our textures now. We're going to load up the right eye for that. And we're going to change the shader to the eye shader. Make sure it's using the proper textures. And just file save. And let's have a look at one using the vertex texture and one using the actual eyes texture. I didn't change anything in the model. I didn't make a change to the QC. All I did was change the actual textures. Matte, reload all materials. Watch these eyes. Which one did I change? The right eye. Watch the right eye. It changed. It went into its proper position. And as you can see, oh, it's using the brown eye. What did I do wrong? Should be iris blue. File save. Now reload the materials. And there we go. So now it's using the blue eye. And as you can see, I've got a little bit of an extra width in the actual iris of the eye compared to the original. And that's all in texturing. Or, let's see, what else can we adjust here? The eyeball radius. Let's pull this one down to 0.8. 0.8. File save. Before I do that, change the actual model number or the model name. File save. And recompile. Remember, we're comparing the QCI to the actual eye that was a combination eye. I haven't changed the left eyeball texture yet, or material yet. Reload the material. Nothing really changed. So now we're looking at a texturing issue. Eye right left, eye up down. Looking down at the view target. Let's change this one. Now the left eye. Copy, Control V, file save, reload the materials, and now we've got the eyes working on the skins as well. Convergence. Make sure that they move with the actual view target. Come in here, grab the view target. Pull it up. Pull it out. Zoom in on the model. And just start pulling the view target around. Now, as you can see, it's floating over top of that eyes white material. And because I didn't remove the bones for that eyes white material, here's a special bonus. I'm going to set the skin back to regular. And here I'm going to find that left and right eye bone. Move in here. I'm going to switch to rotation mode, and I'm going to change my rotation modes to local so that I'm moving both bones on the same local axis, and I can control the amount of shading that I have on those eyes now. And it doesn't affect the iris material. Remember, the iris is floating on top of the actual eyes white material. Okay, I think that is just about it for QC eyes. This is a long video. Yes, I understand that. But like I say, it's a long process. Also, for you guys that like eye refract, I only showed the eyes white shader here, or the eyes shader here. For the actual refract type effect shader, you have to create special textures, but because you already have the coordinates for the eyes, all it is a matter of actually going through and writing up your actual materials and replacing the eyes left and eyes right materials, or whatever materials are running the actual eyeballs. You don't have to do any more recompiling or anything else. The eyes should work if you've done your material, if you've done your textures properly. So with that, I'm going to close off this video. Oh, before I do that, what about the flexes? Well, if you did it properly, your flexes should still all work. Okay, with that, I'm going to close everything off now. I don't think there's anything else I need to say. And with that, I'm going to say private jack out.